Welcome to another video. In this video what we're going to talk about is comparing rational numbers. We'll also cover topics like dividing by zero and those things. So let's go ahead and get started. First off, we want to define what a rational number is. So a rational number is any number that can be written as a over b, where a and b are integers. Remember, integers are positive and negative whole numbers, and b is not zero. And we'll take a look at in a second as to why we can't divide by zero. But let's think up some examples of rational numbers. One example is 4/7. A is 4, B is 7, so 4/7 is a rational number. Another one is 17/1, which we're more comfortable writing as just 17. But that makes all whole numbers rational numbers. Another example is -2/9. We can also have negatives within a rational number because a is a -2 and b is 9. Some examples, some non-examples of rational numbers would be like pi/2. Since a would be pi is not an integer. It's an irrational number, which is the opposite basically of a rational number. 8/0. Again, we can't divide by 0, and we'll take a look at that one here in a second. And 8 divided by the square root of 2. The square root of 2 is also an irrational number, so therefore 8 divided by the square root of 2 is not rational. So let's take a look then at dividing by 0. This is something that we're going to see is impossible to do. So let's take a look at this example of 8 divided by 0. Let's say that we have 8 fish. Now let's say that we want to divide these 8 fish up. So let's try and do it by 0. So if I circle these fish here, I have just divided it up once. So really what this is saying is 8/1. Because I divided it among one person. So that's in my basket. If I tried to divide here, okay, now I've divided it into 2 parts. I divide it here, I've divided it into 4 parts. So this idea of dividing by 0, the idea of dividing by 0 is an impossibility. There is no way that we can divide these fish up without having them in some sort of a basket. They would just be floating there and nobody would possess them, and that's impossible. So when we talk about dividing by 0, it actually comes out to be undefined because it's something that we are unable to mathematically define with a number. All right, next we're going to talk about comparing rational numbers. So there are 3 methods that we have when we compare rational numbers. We can cross multiply, we can find common denominators, or we can convert to decimals. So let's take a look at the first method of cross multiplication. So let's say we have 2 rational numbers. They're in their fraction form. So we have 4/7. Remember, we saw that one earlier when we were talking about what a rational number was. And we have 9/16. So we want to compare these and see which one is bigger. So we can take and cross multiply. So take 4 times 16 and take 7 times 9. And when we take 4 times 16, we get 64. And when we take 7 times 9, we get 63. So we branch out left with our blue 4 times 16, and we get the 64 on the left. And then we sweep out right with our 7 times 9, the orange arrow, and we get 63. So then we ask ourselves, which is bigger, 64 or 63? I would rather have $64 than $63. So therefore, 4/7 is bigger. Let's take a look at our second method of common denominators. So let's say we have -3/5 and -5/9. Now remember, the farther out left on a number line that we go, the smaller the number is. So we're actually looking for the number that's closer to 0. But let's take a look at this. So we can get a common denominator between 5 and 9 by taking -3/5 and multiplying it by 9 over 9, and taking -5/9 and multiplying it by 5 over 5. Because notice how 9 times 5 is 45. And so when we come out with this, we get a -27/45 and a -25/45. And so then we ask ourselves, okay, which number is bigger? Would I rather have -$27 or -$25? Well, I would rather owe someone only $25 as opposed to $27. So therefore, -25/45 is bigger. Or if you want to go back to the original, -5/9 is bigger than -3/5, or you could say -3/5 is smaller than -5/9. Let's take a look at this last method now, method 3 of converting to decimals. So let's say we have 9/25 and 4/11. So we want to look at how can we convert 9/25 into a decimal form. Well, we can take 9 and divide it by 25, and we come out with 36 hundredths. When we take 4/11 and we divide that out, we get 0.36363636. It goes on infinitely in that pattern. So now as we compare these, we want to get to the same place value. So let's add a 0 to this 36 hundredths and make it 360 thousandths. And then let's drop off that 6 on the 0.3636, and now we can compare 360 and 363. And we say, okay, which one is bigger? Again, I think in terms of money, I'd rather have $363 as opposed to $360. So 363 is bigger, and in this case, 9/25 is less than 4/11. The next concept we're going to talk about is called the density property for rational numbers. Now this is kind of a mind-bending thought in that between every pair of rational numbers, remember positive, negative whole numbers, and we have fractions, there are infinitely many rational numbers. So let's take a look at a number line. So if we talk about numbers between 4 and 5, let's say we cut it in half. That'd be 4.5. Okay, let's say we cut 4.5. We go halfway between 4 and 4.5. We have 4 1/4. Let's do that again. We have 4 1/8. And then we have 4 1/16, 4 1/32, 4 1/64. And we could get smaller and smaller, but never hit or reach 4. So there's an infinite number of lines we could draw in there if we wanted to. So let's take a look at finding a number between, and in this case, in our strategy, what we're actually going to be doing is finding a number halfway between two rational numbers. So let's say we have 7/8 and 8/9. Really the goal here, or the strategy here, is that we're going to find the average of the two, where you add them together and divide by 2. So let's start by getting a common denominator so we can add these together. So we look at these and we say, okay, 9 and 8, the first number that they can go into is 72. So we take and we multiply the first fraction by 9 over 9, and we take and multiply the second fraction by 8 over 8, and we get 63/72 plus 64/72. And like I said, we're finding the average, so it's the sum of the numbers divided by the number of numbers, which is 2 numbers. Okay. So we now have 63/72 plus 64/72 divided by 2, which is 127/72 divided by 2. Now, when we divide by 2, it's the same as multiplying by 1/2. So remember, dividing by 2 or dividing by a fraction would be the same as multiplying by its reciprocal. The reciprocal of 2 is 1/2. So then we can take 127 times 1, we get 127. And then we take 72 times 2, and we get 144. So the number halfway between 7/8 and 8/9 is 127/44. Thank you for watching this video. Hopefully it was helpful for you as you continue to work with rational numbers. Thank you for watching.